Okay, so here's our quick little rundown on two problems. We're going to do Joe's problem here, and then we're going to take a look at my own problem that we came up with. So I'm unable to write this up here, it's on the wall, but basically this is TH, okay, for total happiness, all right? This is delta smiley face, so this is change in happiness, okay? And then this formula here shows us the happiness gained per dollar, okay? So the change in happiness over the price of cola in this case. So it's happiness, smiley face, per dollar, okay? So here is our situation. Joe has $8. It costs $1 for a hot dog, and it costs $2 for a cola. All right? He's going to spend all $8, no matter what. So we know that. Okay? So we take a look over here, and what I'm going to do up here first is total cost. I'm going to make a little table for myself. Total product, total P for product, and happiness gained. Okay? So, this is total cost. So as I look up here, some of you are right awake if I ask the question, which should we buy first? Which will bring him most happiness? A lot of you will look right here and say here, because he gains 12 units of happiness. And you'd be correct, okay? Because look, he buys one hot dog, he gets 12 units of happiness. If he buys one cola, he only gets 10 units of happiness, okay? But we're also going to look at what is his happiness per dollar. Because in the end, you want to get as much satisfaction you can per dollar. And what you find out is, by buying his first cola, he actually only earns 5 units of happiness per dollar, okay? Because what you do is you take the change in happiness divided by the price, and colas are $2, okay? So that drops it down to 5. All right? It's easy when something costs only $1, because everything divided by 1 is the same number, which is why these numbers do not change. So be aware of that when you're doing this problem, because later on, you might be using different dollar amounts, and you might not have something that's worth $1, and then this column really comes into play. It does here too, just not as much. So you'd be right. The total happiness gained by buying one hot dog is 12. Okay? So I'm just gonna cross this out so I know. So the first thing we bought was a hot dog. It cost $1. All right? What did we buy? We bought one hot dog. And what was my happiness gained? 12. 12 units. So I'm going to put 12 right here. Okay? Then, what is the second thing we should buy? Okay, some of you may have said, well, the cola, because you gained 10 units here. All right? If you said that, that's okay, but what we're looking at, what you've got to be concerned about is the price per dollar. So you'd be incorrect. Okay? It would be another hot dog, because he gets 9 units of happiness per dollar, whereas here he only gets 5. Okay? So even though overall he gets more happiness, per dollar, it's not a good deal. So, we're going to buy a second hot dog. All right? So another $1, another hot dog, and total happiness gained was 9. So we're going to put that there. Okay? So, look at it again. What should be the third item we buy? I'm hoping you said a third hot dog. Okay, and you're correct. Because the happiness per dollar is 6, and it's still 5 up there. Okay? So we're going to buy another hot dog, and our change in happiness was 6. All right? So good. Oops, I don't know why I'm erasing that. So, that's gone. All right, let's check how much money we've spent here. $1, $2, $3, that means we have $5 left to spend. Okay? So if we take a look, what would be next? And you would be correct by saying we finally are going to buy that cola. Okay? Because now he's getting the best bang for his buck. And we're going to buy a cola. And our total happiness gained here, you might want to put 5, but you actually gained 10 now. Okay, so we're up to 10. Look at this column when you're looking for happiness gained. Alright? So I crossed that off, but it's on the wall, so just pretend that's gone. Alright? So let's take a look at the next thing. What's the next item we should buy? And you're probably saying, well, Mr. O, it doesn't matter. You get the same happiness per dollar. You're correct. So is there a secondary place that we can look? Maybe we look at the total happiness, the total change in happiness. And really, you could either buy a hot dog here, or you could buy a cola. You actually gain more units of happiness overall. It's just that the price or total happiness gain per dollar stays the same. So really, I guess I'll pay for another cola right away. So $2 for a cola, and I gained another 8 units of happiness. Okay, so now 2, 4, 5, 6, 7. We have $1 left. What option does that leave us? Okay, you're right. All we can get left is that hot dog. All right, so we spent that last dollar. We bought 1 hot dog. And what was our happiness, units of happiness gained? 4 more. Okay? So now I can look over here and add this up. 12 and 9, 21, plus 6 is 27, plus 10 is 37, plus 8 is 45, plus 4 is 49. So by buying, what did we buy here? We bought 4 hot dogs. This is the correct combination. And 2 colas. Okay? It's a good day at the ballpark for Joe. He's probably pretty full. We spent a total of $8. Okay? That's how you go about doing this. When you're trying to figure out what should I buy when the final goal is I want satisfaction. Okay? Because in the end, that's what we as human beings want. Alright? So, I'm going to fly over to my other problem here, and we're going to quickly graph that. That's the second step, so just a second. Another thing here I'll take a look at too is 1, and it should say 2, but the pig principle means this. We as consumers, okay, we're not satisfied with what we have. We always want more. That's what consuming means. We want to consume more, okay? And that's something you got to take in consideration when you're studying economics, is consumers always want more. They want the next best thing, all right? And then 2, diminishing returns. As you saw in that graph with Joe, as he bought more colas or more hot dogs, how much satisfaction was he getting out of it? Okay, it was actually getting smaller, wasn't it? Because if you eat 6 hot dogs, I bet you the 6th one doesn't taste as good or as satisfying as the first one, right? That's what diminishing returns is. Okay, in our class, some kids, one student was told to eat a chocolate chip after chocolate chip non-stop. Okay, and they said the first one was a lot better than the 50th. Same thing. Okay, diminishing returns. So keep that in mind. Those are 2 terms you want to know. All right, so here's what a diminishing return graph would look like. We kind of assume that if we have 1 cheeseburger and it satisfies us, the same cheeseburger should satisfy us again the same amount. That's how our brain kind of thinks logically. But actually, you buy a cheeseburger, that was great, okay? You gained a lot there. You buy another one, oh boy, okay? And another one and another one. All of a sudden, this graph starts plateauing. And if it kept going, it might even go downwards, because you're probably going to be throwing up at that point once you have 12 burgers. Okay? Alright, so here's the problem that I created, and I hope you can see that from that far away, but we'll go through it. I'm also going to kind of graph this. All right, and here's the problem. You own a lawn maintenance business, and you are trying to figure out how many workers you should hire. Okay, the goal of this is to basically create as much profit for you as you can. So obviously, here's the table. We've got total workers, and we've got lawns mowed. This would be the independent variable because the amount of workers can affect how many lawns are mowed. The number of lawns mowed cannot necessarily affect the total number of workers. So that's how I figure that out. So we've got workers on the X, and we've got lawns on the Y. All right? So we'll get to the graph later. We just know what's on each axis. All right? So quantity. If we hire 0 workers, we get 0 lawns mowed, and our marginal product is 0. Okay? Marginal product means addition. Okay? Means added to. What else did we gain from this? Okay? And I have a formula here. Total product 2 minus total product 1. Okay? Here's my total product graph here. So, if we hire 1 worker, we will get 2 lawns mowed, and our marginal product would be 2. Okay, so in this case, total product 2 minus total product 1 would be 2 minus 0 equals 2. That's how we get this number. Okay? If we buy another worker, so we have 2 workers, our lawns mowed go up to 7, and we figure out the marginal product, total product 2, which is 7, minus total product 1, which is 2, equals 5. So we get 5 lawns mowed, okay, or 5 extra, more lawns mowed. We buy another worker, we gain another 3, okay. We buy another worker, or hire another worker, we get 2. Another one, we only get 1. Another one, we gain 0. And if we get up to 7 and 8 workers, we actually get less lawns completed, okay. Now, why would that be? We have 8 workers. Shouldn't we be getting more lawns done? Why are we getting less done? Okay, the question is this: what is scarce? And see if you can answer that. What in this, if you own a lawn mowing business, okay, and you hired 8 workers, and you were getting less lawns done than if you were getting only hiring 4 or 5 workers, what is scarce? It is actually most likely because you don't have the supplies to keep all your workers busy. You probably only have 3 or 4 lawnmowers, okay? So if you hire anyone else, they might be raking or doing something else, but anything beyond that, they're going to be in their way, they're going to get distracted, and it's probably going to cause your marginal product to go down, which is interesting because you'd think the more workers I hire, the more lawns I get done. Not the case, because you got to look at your supplies. So, if I were to graph this now, using the X and Y, it would basically look something like this. And I'm not going to go into detail, but I hire 1 worker, I get a bunch of lawns done, or a couple. I hire another worker, I get a big jump. Okay, another, still going up, but it's getting smaller, 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 and then all of a sudden it's going downward. Okay? So here's what this graph would look like if you were the owner of a maintenance company. So to me, I asked my class, put a dot on this graph where diminishing returns basically causes you to gain nothing, okay? And it's basically right around here, all right? That's where you get basically 0. And that would be at about 6 workers over here, okay? Now I asked my class, does this mean we should hire up all the way up to 6 workers and then not hire anyone else? And a lot of people said, yeah, duh, Mr. O, because that's when you get 13 lawns done, and that's the most lawns. You want to get as many lawns done as you can. But I said, you'd think that, but you're wrong. Why? And someone else said, well, because now you're paying for a bunch more workers, but you're not getting that many more lawns done, which means you're probably having to pay your workers, okay, for less lawns, which means you're not getting as much profit. So we said, you know what, maybe we should only hire people up to this point, which would be about, 3 or 4 workers, and you get less lawns done, but it's a smaller margin of lawns getting finished than it is the amount of pay you got to give your workers. And here's what I mean by that. Okay, we're going to do some math over here. So, one lawn earns you $40, okay? And for each lawn, one worker earns $10, okay? So, take a look at this. If we hire one worker, he or she can get 2 lawns done, okay? So if I go 40 times 2, that's 80, all right? And then he gets $10 per lawn, so that's 10 times 2, that's 20, all right? And then I subtract these two because I got to pay my worker, right? This is my expenses. I'm down to $60 profit, all right? So if we buy one worker equals $60, all right? That's my profit. If we hire another worker, we get 7 lawns done in total. We get 5 more lawns done. So 7 lawns times 40. So 40 times 7 equals $280. I only have 2 workers, and 2 workers each did 7 lawns, so that's technically 14 lawns, right? So I go 10 times 14 equals 140. I subtract that, and I make $140 profit that day with 2 workers. Okay? So 2 workers, I get 140 bucks. See how this is working? I buy a third worker. We get 10 lawns mowed. So 10 times 40 is 400, correct? All right. That's 10 lawns mowed for 40 bucks a piece. Now I have 3 workers though, and they each did 10. So really I'm paying for 30 lawns, right? Kind of. Each worker gets 10 lawns worth of pay. So that's 10 times 3 is 30, okay? And then I got to multiply that times 10 because, okay, so this is the number of total lawns I'm paying for. This is the total lawns that these 3 people did. So that's 300, all right? So I do 400 minus 300, and that gives me only $100 profit, okay? So if I hire 3 people, I make 100 bucks. And at this point, you should see that your answer is found, and how many workers should you hire if you want to make the biggest profit. Okay? It would be 2 workers. So, that's a real-life example of looking at your supplies, how much you're earning off of each lawn, and how much you're paying your workers. Now, if you wanted to be able to hire more people, well, then that probably means what? That you have to charge more per lawn, okay? Other factors that could help you improve your profit margins would be perhaps you pay your workers less. That would pump it up. But then again, will people want to work for you? Maybe not. So then you take a look, well, can I have more supplies? If I add more supplies, could that improve the number of lawns that we get mowed? And that would be a yes, okay? If you increase your supplies, that increases your potential to get more lawns done. All right, so there's some initial cost in buying those supplies, but that cost will be paid back as you mow more and more lawns. All right, so that's a more complex example of how making your personal spending decisions based on economic principles. All right, so keep those notes handy and use this information on the test. Good luck.